Now it's time for a little project. Now this I've been wanting to build for a little while. I've finally got all the parts together, and this is sponsored by PCBWay. They provided the circuit boards to me at no cost, so full disclaimer there, they didn't cost me anything. Now I've been building up a collection of parts which I need for this project, and I've put them all in this box. Now I've got everything here, I should be able to build it. So obviously the various parts here I purchased, such as these clips and those cables, these clips, got this cable here, some other parts here, got some, what are these, 120 ohm resistors, I've got some 86.6k resistors, got some 8.2 picofarad capacitors, and I think that is the bulk of that. So let's get on with it and see what PCBWay sent me. Also, don't forget to click like and subscribe if it's the first time here. So PCBWay sent me some boards here, that's one of the orders. There's another one there. They've also sent me some gifts. It's like a little illuminated PCBWay 7. Is it supposed to be a 7? I don't know. Anyway, it's triangular shaped. Got some LEDs around the side, so obviously a little gift there. So you put a little battery in there. It's probably a 2016 or something like that, is it? 2020? I don't know. Yeah, little gift from them. Bunch of PCB rulers. I've got loads of these things now. But I had a bunch of these on my orders as available things to get. It's like a little top up thing, so I've got some more, which gives you an example of the colours they can do. You know, it's all different colours that PCBWay can do. In fact, I think they've got some more now, since they didn't send me these. Nice little selection. Some more stickers. And they've even sent me a shirt. It's nice of them, right? So thanks a lot, PCBWay. So don't forget to check out their sponsorship links down below, because they've sponsored this video by providing me with circuit boards and free stuff. So if you're interested in getting circuit boards made, go and check them out down below in those links. Right, so look at these boards. So like I said, I've got two designs. It's different packaging from them all. Normally they have like a vacuum sealed bag, it's like a bubble wrap bag sort of thing. So they've changed their packaging, which is interesting. Anyway, so this is one set. I'll get the whole lot out first and I'll tell you what it is all about. Okay, this makes more sense that way, I think. And here's the other lot. So these are ENIG gold. Now these are actually quite heavily plated. So this particular board here, as you can see, is like a edge connector. This is a plug which is designed to go into a Siglent scope. Alright, so a Siglent Logic analyzer. And this is somebody else's design. So there's a guy on EV blog forum and a few other people, collection of people on EV blog forum, have put together this design. So this design is a logic analyzer probe for the Siglent 2000X Series scopes, or X Plus Series scopes. I think that's some other stuff too, actually, I'm not sure. I think it might be the 5000 as well, could be wrong about that. So this is basically the connector we're supposed to plug into the front of the scope, and this has got some components that go on there. You also have to put some wire leads on. And then this end here, this is the adapter, which goes off to the actual individual cables and the hook clips and what have you. Scope end there plugs in, you've got wires come out here, which will then come onto this end, and then go out to 0.1 inch header type sockets on this side, which come off the end, and then you can plug in leads and stuff and probe off the channels. So like I said, this isn't my design, this is somebody else's design off the EV blog forum, so thank you very much for that. Whoever did that, it's like a group effort, I think, but mostly one person, I believe, I could be wrong. And this is a multi-layer board, so as you see here, there's a 1 there, you can just see a 2 behind it, and on the back of the board it's got a 4 here and a 3 just behind that. So it's 4-layer board. And it's the first time I've actually had a multi-layer board like this done. I've never done that before, I've only ever used two-sided, 2 layers, one each side. Now these are quite heavily gold plated because it is a plug-in connector, and I wanted to make sure it's got a bit of wear resistance in there. I've had these double ENIG, so this is a ENIG level 2, not single ENIG, but it's 2 layers, twice as thick. So it makes it a bit more robust for use as a connector. Now I think you could do 3 layers, maybe more. This is just what I thought I'd do, that's enough. I thought I'd give it a bit more wear resistance, give it more life, because I mean, it is a connector. If it was just a circuit board which is pretty static, you wouldn't probably worry about it. You might only do a single ENIG for corrosion resistance only. But because it's a connector, I decided to up the game a bit there. So I've got a bunch of boards here, all the same boards, so I only actually need to do one of these right now. So I've got a bunch of different boards because I want to do potentially different variations and maybe different component values, because these do have components put on them. in order to get their matching right. I thought, well, I might need to do different designs, or maybe even different configurations. I might do one for long extension lead on it for Logic probes. I might do some with short ones, or might do different versions. So I thought I'd do a bunch of them and just give me different options. I don't know exactly what I'm going to be doing yet, whether I need to change component values and try different things. And I don't want to be taking parts off a board. I want to make another version because there's not much to it in that way. So the original design for these plug parts are actually supposed to be chamfered on the edge. It's supposed to have like a 30-degree chamfer on both sides to make them easy to plug in. I do want to sort of just machine this a little bit and just put some chamfers on. So on the EV blog page, which I will link down below in the description, it does actually have like a 3D printed jig you can use. You can print it out and then it gives you a perfect angle. You can get a nice sanding angle on it and get 30 degrees out of it. And personally, I'm not going to bother. I'm just going to give it a bit of an edge, take the hard corner off the edge of it and leave it at that. It's probably fine, I think. So I just use this diamond stone I've got here, and it's basically just stuck at an angle like that, and just did that with it. And I've done that both sides. I've got a nice little chamfer both sides now. Maybe that's not the perfect chamfer, I don't care. And I've also done the sides as well. Brought those in a little bit as well to help getting it into the connector, because it is basically a really good fit. So it's exactly the right width for the socket that's on the scope. Having a little chamfer in here will make it a bit easier to plug it in. So I've got this lead-free solder paste over here. I might just try this first, but it's likely to be a bit of a disaster with this stuff. We'll see. It's mostly just liquid, it's not actually paste. Yeah, I know it's just like a mess, so there's plenty on that one. Let's spread it out a bit, make it work. Right, so I'll spread that solder paste around. Hopefully it will sort itself out and not be too much of an issue. I don't have a stencil for this. If this doesn't work, I'll just wipe it off, do it again. I'm not really too worried about it. I'll just have to do it manually with soldering on. But I thought I'd give it a go this way first. So these are the wrong parts. They're capacitors. So these are 120 ohm resistors. I'm just going to place these on first. Let's place all those on. You don't need to see me do this, do you? Right, that's the 120 ohm resistors placed. Now I'm going to do the same thing for the 86.6K resistors. Right, that's the 86.6Ks on there. The capacitors here are supposed to be stacked on top of the 86.6K. But I'm going to do that in one go. I'm going to do it in two stages. Now I've got my little miniware MHP30 hot plate over here. So I'm going to use this to put these things on. Don't forget to click like and subscribe. Right, let's put this board on there. Let's up the temperature. And we'll see what happens. It's all flying very quickly. Got some stuff moving around, which is not what I want. Let's realign those where they're supposed to go. Because that solder paste everywhere, it's always popping around. It's not unsurprising. Let's take it off there for now. Decoordinate it before I put it down. Then I'll give it a clean, because there's solder paste everywhere still solder balls everywhere, because I did it in a really messy way. So I'll clean it up, we'll put it on there again, reflow it again the second time, and we'll see how that goes then. You can see that white area there where there's all the solder paste everywhere. This may or may not work, it might be a mess. So give it a bit of a clean up, got the worst of it off. What I'm going to do now is put some more flux on, reflow the ball with a bunch of flux on it. And that should get rid of the last of the issues with a bit of luck. You know, it's all boiling away, doing its thing. That should tidy up all those solder joints quite nicely. Give some nice joints instead. Okay, that's that ball there done. Those ones on there. I'll get that another clean up, and we should be good then. Oh, actually wait, I need to do the capacitors yet too, so we'll get to that soon enough. Let's just get the worst of the flux off first, and I'll do it again with the capacitors. This time I'll just manually solder those ones on, so it's a bit harder to do with paste like that. Not going to work too well. So as I've got to make up two of these boards, I'll just laid up another one. This one's got slightly thicker paste on it, it's a bit less liquid. I'll try to put a bit less on this time as well, so it doesn't float so much. We'll see how we go. Also reduce the temperature. The temperature is set on to before was a bit too high for it. So let's see how this one goes. It's doing slightly better. Right, before I stick those capacitors on, this is the first board I did. Obviously the second one's over here cooling down. Just measure resistances, make sure I look about right. 86.6. Also, you've got a bit of tolerance there for the resistor accuracy. It's supposed to be 1% resistor, so it should be around 86 to 87. Some are a little bit low, some are bang on. Well, some aren't bang on. That's a bit low. 87's closer, but yeah. 86.8, which is probably one of the closer ones. So it's all kind of there, so it means I've got continuity between each end, which is what it's supposed to do, so that's that one. Let's try the other one, which should have cooled down enough by now. As you can see, there's quite a bit of variance in these part values, but I don't need to think it matters that much, to be honest. Maybe it does, maybe it doesn't. Yep, okay, they're all working. So now I put the capacitors on. So these, like I said, because I've got to stack them, I have to put them on by hand. I'm going to use the original solder and whatever is left of the original flux residue. We'll see if we can do it. What we'll do is basically get them on, get them attached both sides, and then I'll reflow it again. Hopefully it will be okay. At least that's the plan. Because I really think there's actually enough room to put capacitors next to the resistors. But this is the design I've got, to put a capacitor on top of the resistor. A bit tedious. Anyway, that's what it's got. So I'll carry on with this and I'll come back once I'm done. Okay, there we go. Just finished flying those back on. Let it cool down again before I put it down in case I dislodge something. So, like I said, I just put them all on with the soldering iron as I showed you. Then I just went down the other side, did the other side, just tacked them all on with a little bit of solder and reflowed it. If there's anything which didn't make, like there was no solder connection, it would have actually tombstoned. Actually, it did have one tombstoned, and I also had to readjust that, and that wasn't a big deal. That looks like it's basically that board there done now. Do the same thing with the other one. So that's those done. Now we've got to do the actual connector board, which is a bit tricky because it's double-sided. You have to put parts on both sides, so it makes it a little bit harder, but not a big deal. Now I think on this case I'm not going to use paste, I'm just going to use my soldering iron and put those on because it's going to be a bit more precise in this case. We'll do it that way. It's a bit more tedious, but yeah, that's alright. I will still reflow it with my little mini wear thing here. I will still do that. Alright, let's get some. This is my silver solder here, so I'm just going to put some on each pad. Put some flux on, this ain't working. Now, the pedantic side of me wants to put all these in exactly the right spots and have them the right way around, sort of exactly the same orientation, so the text faces the same way on the top of the resistors, but I kind of can't be bothered. That's my lazy side. So I'll do solder both sides and I'll reflow it again on top of the little mini wear and just get it all nice. And then I'll have to have a bit of a difficult time with the other side of it where I've got to try and flip it over and do the same thing again, but I won't be able to put it anywhere for that. I have to do the heat gun for that one, otherwise it will I'll end up dislodging all the components on the bottom of the board, which I don't want, and I can't flip this one over. I'll show you every single component I'm putting on, do I? Do I? Don't think I do. That's full. Quarter of the way there. Alright, that's all on the board. Let's flow it. Get it all nicely done. Really handy little thing this. I'm glad I got this. I actually bought this one. I could have got it maybe for a review, but I paid for this one myself. Rare thing these days. But it would be a good idea. Yep, that's looking good. Now let it cool down to the other side. Just changed tips because I thought the other one I was using was a bit ridiculously big, so I've gone to a smaller tip for this. So I'm using silver solder for this. That's what I use for my precision stuff. I just like to use the better quality solder. Don't forget to click like and subscribe if you find this interesting. Okay, I just used hot air on this. Just letting it cool down now. Once it cools down I can put it down. Alright, so that's all the boards themselves actually made. Now I need to look at doing the interconnect systems. So this is the Tektronix pods which I picked up off eBay. Now these are faulty, it's got a bad connector on here. But this isn't what I purchased them for. I purchased them, well, for this project. I didn't buy these to repair a Tektronix logic analyzer. I purchased these because I wanted the wires. That's it. These could have almost been used as they are. In fact, they might still be able to be if I'm careful. I don't know. But these pods are just connections, right? So it does have 16 connections. This is a 32 port logic analyzer. That's what these are for. And one side is negative, one side is positive on each rail. So 16 cables going to each one. This is a 16 port logic analyzer. So you could almost like wire this onto this board as it is and have that work. In fact, I may even end up doing that too. I might make a board with one of these pods on instead of these custom ones. So let's pull this apart. This might be the right screwdriver. Yes it is. Now, I did pull this apart previously in a mailbag I think and showed the inside of it, so if you missed that maybe have a look at it, I don't know. Look for Tektronix P6434. That's the part number for this thing. So I've already had this apart once before. So it's got a double strip system here. There's the other casing. And it's actually got like a membrane between the two, but like a conductive strip. You'll see it in a second once I get this apart. There you go. So here it is here. That's what connects the board to the actual plug. So let's get one of those out now, so let's figure out which one it is. So it's a nice long wire, 1.5 meters maybe, I don't know. I'll leave that pod on there for now. So this end here has some circuitry on it. So it looks like we've got some resistors or something in series already on this pod. So in a way it's a bit of a shame. This side's also got some components on it. So let's actually measure these, see what they actually are, just out of curiosity. So I checked both of these out, and both sides of the board are 20k resistors. So it's obviously what it's doing is using 20k as its isolation. Well, not suitable for what I'm doing anyway, but this is what will come off. So as it already is all stripped back and all nicely, I want to try and maintain this. Obviously each wire is soldered on and it's got this sealant over the top so it can coming off and having stress on the actual wires. So that's quite a nice setup. And it's also got all the braids all soldered onto the circuit board along the edge. So I want to try and get this off in one go if I can, and then I've got a nice system to put back onto this board, make it a little bit easier without having to strip all these wires off individually and do it all again. Hopefully I can maintain this one. So I've got the wiring all sorted out now, so pulled off those boards obviously and tidied up. Now these pods, which are the original design, are a little bit tricky in my case because it's got the ground connections on this side and the centre conductors on this side. Now for me that doesn't actually suit too well because, you know, I've only got this short length on the wires. So what I think I'm going to have to do is link all these together on this side and then run a wire around to the other side of the ground. I'll probably have to do it in two lots, like 1 to 4 and 5 to, or 1 to 3. 0 to 3, 4 to 8, 4 to 7, whatever you want to call it, I don't know. Anyway, lots of 4. Because it's got the screw holes in the centre as well, which I have to avoid, so I can't just do like one big lump either. So I've got to do like 4 this side, 4 that side, and I'll link a wire around, it has to go around the back of the board, and back onto this side, onto these ground pads here. It's a shame I didn't actually think about that and actually put ground pads on this side as well, because it would have been easy, because that's what this board has got. It's got ground pads there. So it's got a centre conductor and a shield there, which is exactly what these really needed in this particular situation, because it would have worked out a lot better. I mean, if you do using twisting pair, it wouldn't matter, because you just put one side the other side, but I'm using coax, which is better than twisted pair. Small inconvenience, but not too bad. Right, so that's ready for those wires, and I'll split these off into 2 groups of 4 and then put them on there. Alright, so that's those mounted on there. Not the prettiest thing, but it will do the job hopefully. It's a bit hard doing this side because the wires are really fragile as well. I ended up breaking one. I had to cut it back a little bit and fix it, but anyway, it's that side done. Yeah, not ideal, but it'll do the job. So I've just got all the shields soldered down. Shields soldered down. What I did is I put solder on the board and I soldered up the actual shields together on the back of the ribbon, and I just left the soldering iron on and put it basically sandwiched between the two, and then I pulled the soldering iron out as I pushed them together, and that soldered those down. I think these wires are like Teflon or something. They seem to be pretty heat resistant. Anyway, I shall now solder down all the individual conductor strands, and then that'll be one half of the pod made. I'll have to repeat the process for the other half as well, and then we can do some testing. So that's those soldered on now, so that's that part done. Right, let's check for any shorts. So I've got on the ground connection down here. First check the ground, make sure we've got a connection. Yep, that's good. Now let's check the actual conductors. I'm going to put on the end of resistors here. Nothing. Excellent, no shorts. So that's looking good in that way. Let's flip this over and check the conductors themselves, each end. So I think 7's this end. Looking good. Now let's check for shorts in between the conductors. Nothing. Excellent. That one should work. Now also on the actual pod, I've still got to put on a female header. I've got to find some. I'm sure I've got some dual inline female headers here somewhere. So once I find those, I'll fit those on there. But I've got to find the things first. So I've done this board. I've done it a little bit differently, based on the fact I had some difficulties with the first one. Is I've put on the earth connections first and got them in place. So all I've got to do now is actually slide the cable in, attach these shields, which should take a bit of stress off the cable and help keep it more stable. Then I'll attach all the conductors individually, and hopefully that should mean I get less breakages and a bit less stress on the wires, because that's the most dodgy thing is if I break them too far back, I'm going to strip the whole cable off and start again. I don't want to go there. So there you go, the shield's connected up. That means it's much more stable now, and less likely to put any stress on those other conductors. So I'm going to spread those a little bit, get it all positioned exactly where I want it, and solder them all on. So I've just done the first 4, let's just do the next 4. Right, that should be that end done. Alright, so those soldered on, that's all those connections done. I've already tested them, there's no shorts or anything like that, it's all working as it should do. Now I'm going to seal them all up with some of my electrical tape here. Just get it so it's all stabilised, so it's not likely to be having any stress causing breakages, stuff like that. This side of this board wasn't as nice as the first one I did. The other side was a lot tidier because I put the ground side downwards, but this side the cables had to be this way up. So I had to put a strap across the top here to act as an earth. So not as good as the first time. First side is better. So something I remembered I had is this angle join line. So I did actually have some of this one. It's not perfect, but it will do the job. So what I've done is I've gone through, cut off some of the pins. These big angle ones here, the outer ones, I've cut those off at the angle on the elbow, which is this side. And the other side, I've bent those straighter. Not completely straight, but they're straighter. And this means I can then basically stick on the board like that. And I can solder those down, and that'll be okay. I'll hold it in, I'll have to tweak this a little bit and get that straight. It's not a big deal. Let's make sure when I solder the first couple of pins I'll get it straightened up. That'll be okay. So what I'm doing right now is actually printing out the shells on my 3D printer. So that's currently working, and we'll see. The main thing I'm not sure about is this one here, because I've got this big lump on his side for the 0 volts grounding, shielding. I'm not sure if it's going to be clear of the shell or not. I might have to do some tweaks or possibly make a different kind of shell. We'll see. But the first thing is, let's get these connectors on. Right, testing time. Don't forget to click like and subscribe. So I've got both the pods connected straight into this Siglent STB3, which is a test board which generates all kinds of signals for testing oscilloscopes and logic analyzers and things like that. It does all sorts of stuff. But what it's got here is 2 headers which are both 8 channel outputs for, well, parallel channels basically, 8 parallel outputs. So you can see a binary representation on a scope or a logic analyzer or whatever. So you can see I've got both hooked up here. Now I had to do some rectifications. When I did this, when I had a couple of wires that broken, I thought I'd fix them, but no, I had problems with them, so I ended up cutting it back and doing it again. I had one wire over here which I was able to splice back on a little bit, so that's okay. So these are alright, but this wire is really fragile and a bit of bad luck in a couple of things. So I'll show you the scope. So there you go, there's a scope showing all the waveforms. Obviously I've stopped it, otherwise there's jitters around everywhere, but that shows that all the 16 channels are working. The 16th one is under here, which is underneath the binary heading here. So setting the binary up gives you the binary value, but I don't know if you'll be able to see it here. Gives you the binary representation, tells you what it is. So that's all that is. It's just overlapping that other one there. So maybe a Siglent do see this, or Rob, I'm sure you'll show this to Siglent, or maybe mention it to them at least, if I forget to tell you. Get them to get it so this binary display can be put underneath the channels, because right now, no matter where you put it, you're overlapping on top of one of the channels. This binary display, it's in the way. Bit annoying really. Let's go over here to bus. You've got the bus 1, bus 2. Oops. Bus 2. Either one. I'm only using bus 1 right now. Display is on. And that's turned it off there. So there's channel 15 there. Alright, so it is doing stuff. There you go. It's got to drop down just there. But when you turn the display on to show the binary representation, it's overlapping it. You can't actually put it any further. That's all the way down the screen. I can't put any lower than that. So really, that's a bit annoying. It would be nice if it wasn't overlapping the data, because you want to see the waveform, see if it's there, but it's overlapping it. Bit annoying. So also it's gone in there, gone to the channels and turned off half the channels. So it expands all the rest of them to fill the space, which is nice. That's good. Then it's using all of your screen real estate, which is good. But I've still got this issue with this overlapping. So Siglent need to do something about this binary data here and make sure that it allows some space for that. So if you've got it turned on, it squashes the rest of this up a little bit to allow for space for it, because it's kind of annoying. If you want to try and read that, it's overlapping the waveforms. If I don't know which ones I use, if I turn those ones all the way on, turn those ones back off, it's still there in the way. So interesting thing I did find when I was looking at these is that there's a resistor inside here. I measured the resistance of this cable and I discovered it's got 89k resistance. So there's actually a resistor inside here. What that means is that these are equivalent of one of these pods. Well, these pods. Right, it's equivalent of one of these, because this is 86.6 plus 120 ohm. So 86.8 or so, and it is 89k. Whether that few extra k matters, I'm not sure, but what it probably means is that I could probably make another version which doesn't use these pods and use the original HP pod instead with these cables on it, because it seems to make sense to do that. I think that's something I could actually do. Now I've got a big mess to clean up. Don't forget to click like and subscribe if you found it interesting, and I'll catch you later. Bye.